November 14, 1942. Imperial Japanese Navy Technical Arsenal, Yokosuka. Commander Takeo Nakajima's hands trembled slightly as he connected the power supply to the salvaged equipment before him. The device, retrieved from a downed American aircraft 3 weeks earlier near Guadalcanal, looked deceptively simple. A rotating antenna assembly, a cathode ray display, power distribution units humming with unfamiliar transformer configurations. "This cannot be accurate," he muttered to his assistant, Lieutenant Hiroshi Yamada, as the display flickered to life. No radar system can reliably detect aircraft at these distances while maintaining positional accuracy. Through the laboratory windows overlooking Tokyo Bay, Nakajima could see the aircraft carrier Zuikaku undergoing repairs from battle damage sustained 2 months earlier at the Battle of Santa Cruz. Tangible evidence of American naval aviation's growing effectiveness. Yet here, on his workbench, lay physical proof that the technological gap was far more dangerous than anyone in the combined fleet had dared to admit. The radar set before him, extracted from the wreckage of a U.S. Navy TBF Avenger torpedo bomber shot down during the naval battle of Guadalcanal on November 13, operated at frequencies the Japanese naval technical staff had dismissed as impractical for shipboard use. The Americans called it the SC radar, an air search system that could detect aircraft formations at ranges exceeding 160 kilometers, 100 miles. It was a capability that rendered obsolete every tactical doctrine the Imperial Navy had developed for carrier warfare. What neither Nakajima nor his colleagues yet understood was that this single radar set would explain a mystery that had been costing the combined fleet aircraft and irreplaceable veteran pilots at unsustainable rates. A hemorrhaging of air power that threatened to lose Japan control of the Solomon Islands within months. The mathematical certainty of Japanese defeat in the air war was being written not in fighter tactics or pilot skill, but in electromagnetic wavelengths that Japanese technology could not match. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The psychological transformation had begun on that humid morning at Yokosuka. The path to this moment of revelation had started months earlier in the tropical waters off Guadalcanal, where Japanese naval aviators had been encountering increasingly disturbing evidence of American detection capabilities that seemed to border on supernatural. The night engagement of August 8 to 9, 1942, during the Battle of Savo Island, had provided the first hints that something fundamental had changed in naval warfare. Vice Admiral Gunichi Mikawa's cruiser force had achieved a stunning tactical victory, sinking 4 Allied cruisers in a night surface action. Yet the American ships, despite being surprised and defeated, had demonstrated an uncanny awareness of Japanese ship movements in complete darkness. Their initial positioning and response times suggested detection capabilities beyond what visual spotting or sound ranging could explain. Captain Tameichi Hara, commanding the destroyer Amatsukaze during the battle, filed a report that typified the growing unease among Japanese surface commanders. "The enemy cruisers maneuvered as though they could see us in darkness," he wrote in his action report submitted to Vice Admiral Mikawa's staff. Their initial salvos, though poorly aimed due to surprise, indicated they had detected our approach long before visual acquisition should have been possible. Either American lookouts possess extraordinary night vision, or they employ detection equipment superior to our Type 21 air search radar. We achieved victory through aggressive action and superior torpedo tactics, but the Longling, Americans demonstrated technical capabilities we do not fully understand. Similar reports accumulated throughout September and October 1942 as carrier battles raged in the waters surrounding Guadalcanal. Japanese strike aircraft launching from carriers positioned 200 to 300 kilometers from their targets were consistently intercepted by American fighters that seemed to have advanced warning of their approach. The Americans appeared able to vector their Wildcat fighters with precision that suggested they could track Japanese formations from distances far exceeding what Japanese radar technology could achieve. Lieutenant Commander Takahide Aioi, a veteran bomber pilot who had participated in the Pearl Harbor attack, led a strike against American carriers during the Battle of the Eastern Solomons on August 24, 1942. His after-action report revealed profound confusion about American defensive capabilities. "We approached the American task force at wave-top altitude to avoid radar detection," Aoi reported to his squadron commander aboard carrier Shokaku. Yet American fighters were positioned perfectly to intercept us 40 kilometers from the carrier formation. The combat air patrol appeared to have been vectored to our exact approach path despite weather conditions that should have prevented visual detection. Our formation was engaged before we achieved attack position, suffering 30% losses before launching torpedoes. Either American reconnaissance is far more effective than our intelligence assessments suggest, or they possess radar systems capable of low-altitude detection at ranges we believed impossible. The statistics told a grim story that would become catastrophic by late 1942. In the Coral Sea Battle of May 1942, Japanese carrier aircraft had achieved roughly equal exchange rates with American naval aviation, though Japan lost the light carrier Shoho and saw Shokaku severely damaged. At the Battle of Midway in June, catastrophic losses of 4 fleet carriers destroyed Japanese naval aviation's striking power, but those losses could be attributed to tactical errors and unfortunate timing rather than American technological superiority. However, in the grinding attrition battles around Guadalcanal from August through November 1942, a disturbing pattern emerged. Japanese aircraft were being lost at rates approaching 3-1 against American defenders, who seemed to possess uncanny ability to position interceptors exactly where Japanese strikes would appear. The Battle of the Eastern Solomons on August 24 saw Japanese carrier aircraft lose approximately 60 aircraft, while sinking no American carriers and damaging only Enterprise. The Battle of Santa Cruz on October 26, Japan's last tactical victory in carrier warfare, cost the combined fleet over 100 aircraft and numerous experienced aircrew in exchange for sinking Hornet and damaging Enterprise. The exchange rate, once heavily in Japan's favor during the first 6 months of war, was collapsing at an accelerating pace that threatened to exhaust trained carrier aircrew faster than training programs could replace them. Vice Admiral Chuichi Nagumo, commanding the First Air Fleet that had struck Pearl Harbor 11 months earlier, watched these numbers with growing alarm from his headquarters ashore at Truk. His staff maintained detailed plots of every carrier operation, every airstrike, every engagement. The patterns emerging from these plots made no sense according to conventional carrier warfare doctrine. American fighters appeared able to intercept Japanese strikes with impossible consistency, suggesting they possessed advance warning beyond what reconnaissance aircraft could provide. Japanese scout planes reported American carrier positions accurately, yet when strike aircraft arrived at reported coordinates, they often found American ships had maneuvered significantly, while American fighters were positioned perfectly for interception. Most disturbing, American task forces seemed able to detect approaching Japanese aircraft and launch additional fighters, even when weather conditions prevented visual spotting or when Japanese strikes approached from unexpected bearings. Commander Minoru Genda, senior air operations officer on Nagumo's staff and principal architect of the Pearl Harbor attack plan, spent weeks analyzing combat reports seeking explanation for the mysterious American defensive efficiency. The pattern was clear but incomprehensible. American detection and fighter direction capabilities had improved dramatically over a very short period between mid-1942 and late 1942, suggesting new technology rather than improved tactics or training. But what technology could detect aircraft formations at ranges exceeding 100 kilometers? What could track low-flying torpedo bombers approaching at wave-top altitude? What could vector fighters with such precision that they consistently intercepted Japanese strikes at optimal defensive positions? The questions multiplied faster than answers could be found. Genda convened meetings with Japan's top naval aviation specialists and radar experts throughout October and November 1942. The discussions revealed disturbing ignorance about American capabilities and troubling complacency about Japanese technological adequacy. Japanese radar experts insisted that shipboard air search radar was fundamentally limited by antenna size, ship motion, and power generation constraints. The Type 21 air search radar equipping Japanese carriers could detect aircraft at ranges approaching 100 kilometers under ideal conditions, with the more common detection occurring at 60 to 80 kilometers. This was considered adequate for carrier defense, providing approximately 30 to 40 minutes warning before attacking aircraft could reach launch positions for bombs or torpedoes. The Americans, Japanese experts argued, faced the same physical limitations. Their radar technology might be slightly different in implementation, but the fundamental physics of radio wave propagation imposed identical constraints on all nations. If Japanese radar could detect aircraft at 100 kilometers maximum range, then American radar could not significantly exceed this capability. Therefore, American defensive success must derive from superior fighter direction procedures, more aggressive combat air patrol tactics, or perhaps better training of radar operators rather than fundamentally superior radar technology. Some specialists speculated that the Americans had developed better radar sets for specific functions, perhaps improved height-finding capabilities or better low-altitude detection. Others suggested the Americans might be using radar in combination with superior voice radio and communications to coordinate fighter interceptions more effectively. A few voices mentioned rumors of American radar developments beyond Japanese capabilities, but this was largely dismissed as unlikely. Japan's scientists and engineers were world-class. If Japanese research had concluded that certain radar capabilities were impractical given available technology, then they must be impractical. The Americans could not possibly have solved fundamental physics problems that had defeated Japanese engineering. This complacent certainty would shatter completely when Nakajima's team at Yokosuka Naval Arsenal began examining the Guadalcanal device. The radar set had arrived at Yokosuka on October 24, 1942, accompanied by photographs of the complete installation and detailed reports from the recovery team. The TBF Avenger, Bureau number 00373 from Torpedo Squadron 8, operating from the carrier Enterprise, had been shot down during the Battle of the Santa Cruz Islands on October 26 by anti-aircraft fire from the cruiser Tone. The aircraft had crashed in shallow water near one of the smaller islands in the Santa Cruz group. Japanese Navy landing forces searching the area 3 days later discovered the wreck partially submerged but relatively intact. The electronics equipment in the aircraft appeared salvageable. A technical recovery team was dispatched from Rabaul with orders to extract any intact radar or radio equipment for analysis. What they recovered exceeded the expectations of anyone in the combined fleet technical staff. The TBF carried not only its own airborne radar, designated ASB by the Americans, but also detailed technical manuals and maintenance documentation. More critically, several components had manufacturer labels and technical specifications visible on the equipment itself. The recovery team carefully extracted the complete radar system, photographed the installation, and transported everything to Truk, where it was transferred to a fast cruiser for immediate transport to Japan. Commander Nakajima, one of the Imperial Navy's few specialists in radar technology, with advanced training in radio frequency engineering from Tokyo Imperial University, assembled Japan's top electronics engineers for what would become an intensive examination lasting 3 weeks. Their task was to determine exactly what capabilities this American radar possessed, how it achieved those capabilities, and most critically, whether American surface ships possessed similar or superior technology. The first examination on November 1st revealed the radar's basic specifications through careful study of the technical manuals recovered with the equipment. The American designation SC radar operated at frequencies between 70 and 120 MHz, corresponding to wavelengths of approximately 2.5 to 4 meters. This was similar to frequencies used by Japanese Type 21 radar. The antenna, however, revealed sophisticated engineering far beyond Japanese capabilities. The SC antenna consisted of a bedspring configuration, approximately 4 meters wide and 3 meters tall, rotating continuously at 6 revolutions per minute. The design provided 360-degree coverage with relatively narrow beam width for accurate bearing determination. More significantly, the antenna mounting system incorporated sophisticated servo motors and bearing assemblies that maintained stable rotation even on a pitching, rolling ship at sea. Japanese radar antennas, by comparison, used simpler rotation mechanisms that often required manual positioning or suffered accuracy degradation in rough seas. Dr. Hideaki Yagi, the physicist whose name would later be associated with the Yagi-Uda antenna design, examined the American radar transmitter with professional admiration bordering on despair. The power output specifications listed in the technical manual indicated 15 kilowatts peak power, he reported to Nakajima during the initial assessment meeting. This is 3 times the power output of our Type 21 radar. The pulse repetition, frequency, and pulse width parameters suggest this radar can detect aircraft at ranges we considered impractical for shipboard installations. The Americans have not merely refined our approach to naval radar, they have exceeded our capabilities through superior power generation and signal processing. But the true revelation came when Nakajima's team powered up the radar display unit using laboratory power supplies and carefully calibrated the system according to the American technical manual. The plan position indicator display, an American innovation that presented radar returns on a circular screen with the ship at the center and bearing marks around the perimeter, provided intuitive tactical awareness impossible with the A-scope displays used on Japanese radar sets. More shocking was the effective detection range documented in the American operational manual. The SC radar, according to U.S. Navy documentation, could reliably detect large aircraft formations at ranges exceeding 100 nautical miles, approximately 185 kilometers, under favorable conditions. Single aircraft could be detected at 70 to 80 miles, approximately 130 to 150 kilometers. Low-flying aircraft approaching at altitudes below 1,000 feet could still be detected at ranges of 40 to 50 miles, 75 to 90 kilometers, far exceeding Japanese low-altitude detection capabilities. Lieutenant Yamada, assisting Nakajima with the technical evaluation, was the first to fully articulate the implications. If American carriers possess radar systems with these capabilities, he stated during the examination team meeting on November 7, 1942, then every tactical assumption governing our carrier strike operations is obsolete. Our doctrine assumes we can approach within 200 kilometers of enemy carriers, launch strikes, and achieve surprise, or at minimum face defenses that are only beginning to react. Instead, American radar will detect our aircraft when they are still 100 to 150 kilometers from their target. American carriers will have 30 to 40 minutes to launch additional fighters, position combat air patrol optimally, and prepare defensive anti-aircraft fire. We will never again achieve the tactical surprise that was decisive at Pearl Harbor. The examination continued for 2 more weeks, as Nakajima's team reverse-engineered every component, photographed every circuit, and translated every page of technical documentation. What emerged was a comprehensive picture of American naval radar capabilities that far exceeded Japanese intelligence estimates. The SC radar represented only one system in a coordinated suite of radars aboard American carriers and accompanying warships. Other American radar systems discovered through intelligence reports and previous captures included the CXAM and SK systems for long-range air search and the Mark IV fire control radar for directing anti-aircraft guns. Each system operated at different frequencies optimized for specific functions, creating layered detection coverage that provided American task force commanders with comprehensive awareness of the airspace surrounding their ships. Japanese carriers, by comparison, typically carried only 1 or 2 radar sets, with many escorts having no radar at all. The technological disparity was becoming undeniable. On November 14, 1942, Nakajima presented his findings to senior Combined Fleet Staff officers at Naval General Staff Headquarters in Tokyo. Captain Kameto Kuroshima, senior operations officer to Admiral Isoroku Yamamoto, attended representing the combined fleet commander. The mood was somber as Nakajima delivered his assessment. "We must report with complete frankness that American naval radar capabilities significantly exceed our own," Nakajima began. "The SC radar examined represents a mature, highly effective air search system that provides detection ranges approximately 70% greater than our Type 21 radar. More critically, the technical documentation indicates this radar has been in service aboard American carriers since mid-1941, meaning the Americans possessed this technological advantage before the war began. Our intelligence estimates of American radar capabilities were incorrect by a factor of nearly 2. The presentation detailed the technical specifications with precision that left no room for optimistic reinterpretation. Detection range for large formations exceeded 100 miles. Single aircraft detection approached 70 miles. Low-altitude coverage far exceeded Japanese capabilities. Plan position indicator displays provided superior tactical awareness compared to Japanese A-scope presentations. Antenna rotation mechanisms maintained accurate bearing determination even in heavy seas. Power output exceeded Japanese radar by factors of 2 to 3. Manufacturing quality indicated established mass production rather than experimental prototypes. The implications were devastating. If American carriers possessed radar with these capabilities, and intelligence reports suggested they did, then Japanese carrier strike doctrine faced fundamental obsolescence. The entire concept of achieving surprise through long-range strikes launched from carriers positioned 200 to 300 kilometers from the target depended on remaining undetected until attack aircraft were nearly in position. American radar eliminated this advantage completely. Captain Kuroshima absorbed the briefing with growing understanding of the crisis facing Japanese naval aviation. He had served as Admiral Yamamoto's operations officer since before the war, planning the Pearl Harbor attack and subsequent operations. His tactical acumen was renowned throughout the fleet. Now he faced technical reality that undermined the strategic assumptions upon which Japanese naval strategy rested. "If American radar provides 40 minutes warning of our strike aircraft," Kuroshima stated slowly, thinking through the tactical implications aloud, "then American carriers can launch additional fighters, position combat air patrol for optimal interception, and coordinate their defensive response with unprecedented effectiveness. Our strike aircraft, approaching at speeds of approximately 300 km per hour, will cover the final 100 kilometers in approximately 20 minutes. American fighters, launched immediately upon radar detection, will have time to climb to altitude, receive vectoring guidance from their carriers, and position themselves exactly where our strikes will appear. The Americans need not maintain standing combat air patrols of overwhelming size. They can rely on rapid launch and precise interception based on radar warning. The strategic implications extended beyond immediate tactical concerns. Japanese naval strategy for the Pacific War assumed that superior training and combat experience of Japanese pilots would provide decisive advantage in carrier battles. The calculation presumed roughly equivalent detection and engagement capabilities, with victory determined by pilot skill and aggressive tactics. But if American technology provided such comprehensive detection advantage that Japanese strikes were consistently intercepted before reaching attack positions, then pilot quality became irrelevant. Superior airmanship could not overcome the fundamental disadvantage of fighting enemies who detected you first and positioned their defenses optimally before you arrived. Worse yet, the examination of the Guadalcanal radar confirmed that American manufacturing quality and production methods far exceeded Japanese capabilities. The radar components showed sophisticated mass production techniques. Standardized connectors and replacement parts suggested logistics systems that could maintain radar equipment at sea for extended periods. Component reliability appeared excellent based on the condition of equipment recovered from a crashed aircraft. Everything pointed to mature industrial processes producing radar in quantities Japan could not match. Commander Yoshio Ozawa, attending the briefing as representative of the Naval Technical Department, provided the most sobering assessment. Even if we immediately prioritize radar development and production, he stated, we cannot close this technological gap before 1944 at the earliest. Our electronics industry lacks the production capacity, the component manufacturing infrastructure, and frankly the engineering expertise that American firms have developed. The Americans are not merely ahead, they are operating on a different industrial scale that Japan cannot replicate given our resource constraints and competing demands from other weapons programs. We are fighting a technological war we entered already behind, and with no path to parity. The meeting at Naval General Staff Headquarters concluded with several devastating conclusions that were documented in classified reports, later captured by American forces after the war. First, Japan could not replicate American radar capabilities in operationally significant numbers before 1944 at the earliest. The precision manufacturing required for radar components, the specialized electronic tubes, the sophisticated power supplies using transformers that Japan lacked capacity to produce in quantity, and the engineering expertise required were all beyond immediate Japanese industrial capabilities. Even a crash program would take months to yield prototype systems, with mass production extending well into 1944 or 1945. Second, developing effective tactical countermeasures would require fundamental revision of carrier strike doctrine. Japanese aircraft would need to approach American task forces at extremely low altitudes to minimize radar detection ranges, but this would increase fuel consumption and reduce strike range. Alternatively, Japanese carriers would need to close to within 100 kilometers of American forces before launching strikes, but this would expose the carriers themselves to American counterattack before Japanese aircraft could suppress the threat. Neither option provided acceptable solutions. Third, and most devastating from a strategic perspective, the Americans almost certainly possessed even more advanced radar systems beyond what had been captured. The SC radar dated from 1941 according to technical documentation. American electronics firms, with access to superior manufacturing capacity and materials, had certainly developed improved systems during 1942. Intelligence reports mentioned American ships equipped with multiple radar sets, each optimized for different functions. The technological race was not merely lost, it was unwinnable in the war's current timeframe, given the American head start and vastly superior industrial capacity. Admiral Isoroku Yamamoto, Commander-in-Chief of the Combined Fleet, received briefings on the Yokosuka examination in late November 1942. His headquarters, which had relocated to the super battleship Yamato at Truk Lagoon, maintained detailed assessments of every engagement, every loss, every tactical development. The reports on American radar capabilities confirmed his pessimistic assessment that Japan could not win a prolonged war against American industrial might. Yamamoto had opposed war with the United States from the beginning, famously warning that Japan might achieve victories for 6 months to a year, but could not sustain success against American production capacity. Now, barely a year into the conflict, his prediction was proving accurate. The examination of captured American radar provided technical evidence of the industrial and technological superiority he had feared. "We have been granted our 6 months," Yamamoto told his Chief of Staff, Vice Admiral Matome Ugaki, during discussions in late November 1942. The victories at Pearl Harbor, in the Philippines, in the Dutch East Indies, they purchased time but not victory. Now, American production and American technology are overwhelming our advantages in training and experience. This radar discovery confirms what I have long feared. We cannot win a technological competition against American industry. The question facing Yamamoto and the Combined Fleet staff was what could be done while German industry and Japanese training programs scrambled to develop countermeasures that might not arrive until late 1943 or 1944. Captain Kameto Kuroshima proposed several tactical adaptations based on the Yokosuka findings. All carrier air groups would be informed that American radar provided extensive warning of approaching strikes, and that surprise should no longer be assumed. Strike aircraft would be instructed to approach at minimum altitude whenever possible. accepting increased fuel consumption in exchange for reduced radar detection ranges. Carrier formations would attempt to close range before launching strikes, even though this increased risk to the carriers themselves. Most critically, Yamamoto and his staff began preparing for the possibility that carrier aviation could no longer achieve decisive results against American task forces equipped with advanced radar. If Japanese strikes were consistently intercepted short of targets, suffering unsustainable losses without inflicting equivalent damage, then the carrier force risked annihilation through attrition rather than climactic battle. Alternative strategies, emphasizing land-based aviation, submarine operations, and surface night actions would need greater priority. December 1942 and January 1943 proved Nakajima's analysis correct with brutal clarity. Japanese carrier aircraft attempting to support operations around Guadalcanal were systematically destroyed by American fighters that seemed to possess perfect situational awareness. The Americans had reinforced their positions with additional carriers, including the repaired Enterprise and the newly arrived Saratoga, giving them numerical superiority in both ships and aircraft. More critically, American radar provided such comprehensive air defense coverage that Japanese strikes rarely achieved surprise. Lieutenant Takeshi Maeda, a veteran Zero fighter pilot with 12 confirmed victories, participated in multiple strikes against American ships off Guadalcanal during this period. His diary, discovered after the war, documented the progressive demoralization caused by American radar-directed defenses. December 8, 1942, he wrote. Led a strike against American transports reported off Lunga Point. We approached at wave-top altitude as instructed, hoping to avoid radar detection. American Wildcat fighters intercepted us 30 kilometers from the target, positioned perfectly across our approach path. We lost 4 aircraft before even sighting the enemy ships. The Americans knew we were coming. They were waiting for us. January 14, 1943. Another strike against shipping. Same result. American fighters met us at optimal interception point. Our formation was shattered before reaching attack positions. We are being led to slaughter. American technology has made our tactics obsolete. I do not know how we can achieve victory when the enemy sees us coming from distances we cannot match. The statistics told the grim story with mathematical precision. In December 1942, Japanese land-based and carrier aircraft operating from Rabaul and Truk lost approximately 120 aircraft in operations around Guadalcanal while achieving minimal success against American ships. January 1943 saw similar losses with equally negligible results. The exchange rate had become catastrophically unsustainable. Japan was losing veteran pilots faster than training programs could replace them, while American pilot training schools were producing fresh aviators in ever-increasing numbers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The final collapse of Japanese carrier aviation effectiveness came in the series of battles throughout 1943 that demonstrated complete American air defense superiority. The air battle over the Russell Islands in April 1943, designated Operation I-Go by Japanese planners, was intended to regain Japanese air superiority through massive commitment of land-based and carrier aircraft. Admiral Yamamoto personally traveled to Rabaul to oversee the operation, committing over 300 aircraft to strikes against American positions in the Solomons. The results were disastrous. American radar detected every Japanese raid, while formations were still 100 or more kilometers from their targets. Fighter directors aboard American ships and at land bases vectored interceptors with precision that Japanese pilots found incomprehensible. Of approximately 350 Japanese aircraft committed to Operation I-Go between April 7 and April 16, 1943, over 100 were destroyed while American forces lost approximately 30 aircraft. Japanese pilots reported achieving great victories, claiming dozens of ships sunk and hundreds of aircraft destroyed. Post-war analysis revealed these claims were almost entirely false. the result of wishful thinking and poor battle damage assessment. The Americans had suffered minimal actual losses, while Japanese air strength around Rabaul had been gutted. Captain Yahachi Tanabe, commanding the submarine I-168, observed American task force operations during periscope reconnaissance missions in mid-1943. His reports to Submarine Force Headquarters described the visible evidence of American radar superiority. American carrier task forces operate with complete confidence in their detection capabilities, Tanabe reported in May 1943. I observed American carriers conducting flight operations with minimal combat air patrol overhead, suggesting they rely on radar warning rather than standing fighter coverage. When our aircraft approached, I witnessed American carriers launching additional fighters with remarkable speed, vectoring them toward our strikes while they were still beyond visual range. The Americans have created an invisible shield around their ships that our aircraft cannot penetrate without suffering prohibitive losses. The interrogation reports from captured Japanese pilots provided American intelligence with valuable confirmation of the radar advantage. Ensign Kiyoshi Ogawa, shot down during an attack on American shipping near New Georgia in July 1943 and rescued by American forces, provided detailed testimony during questioning at the prisoner of war facility on Espiritu Santo. We knew by mid-1943 that American radar was superior, Ogawa told his interrogators during sessions conducted in August 1943. The interrogation transcripts, declassified decades later, reveal the profound impact of technological inferiority on Japanese pilot morale. Our briefings before missions included warnings that American fighters would be positioned exactly where we approached, that we would be intercepted before reaching attack positions, that survival depended more on luck than skill. Many pilots no longer believed we could achieve our missions. We flew because duty demanded it, not because we expected success. The Americans asked how we knew about their radar. We knew because we never achieved surprise after early 1942. Every attack was met with fighters positioned perfectly. Every approach vector we tried resulted in interception. Our commanders told us the Americans had superior radar. They captured one of our planes with radar equipment and now understand our capabilities while we cannot match theirs. It was profoundly discouraging to know the enemy possessed technology that made our training and sacrifice meaningless. Lieutenant Commander Masatake Okumiya, who served as a staff officer with the 11th Air Fleet at Rabaul, wrote extensively about the impact of American radar superiority in his post-war memoir, Zero Fighter, co-authored with Jiro Horikoshi and Martin Kadin. The book, first published in 1956, provided valuable Japanese perspective on the technological challenges facing Japanese naval aviation. The Americans' radar-directed fighter interceptions destroyed our offensive capabilities more effectively than superior pilot training or aircraft performance, Okumiya wrote. By mid-1943, we understood that every strike we launched would be detected while still 100 kilometers from the target. American fighter directors would vector interceptors to meet us at optimal positions. Our losses became unsustainable, while our successes became negligible. We were fighting an enemy who could see us from distances we could not match, who could coordinate defenses we could not overcome, and who possessed industrial capacity to replace losses we could not equal. Japanese technical efforts to develop counter-radar capabilities or improved radar systems consumed enormous resources with minimal operational impact. The Naval Technical Department accelerated development of improved air search radars throughout 1943, but the systems that emerged remained inferior to American equipment. The Type 13 radar, entering service in limited numbers in late 1943, provided improved detection ranges approaching 120 kilometers against large formations. However, production remained limited due to component shortages and competing demands from other weapons programs. By the time improved Japanese radars reached the fleet in significant numbers, American forces had developed even more advanced systems that maintained the technological advantage. Radar warning receivers that could detect American radar emissions and provide warning to Japanese pilots were proposed but never successfully developed. The technical challenges of building receivers, sensitive enough to detect American radar at useful ranges, while compact enough for aircraft installation, proved insurmountable, given Japan's limited electronics expertise and industrial capacity. German radar warning receiver technology, shared through technical exchanges between Axis powers, could not be adapted to Japanese requirements before the war ended. The Battle of the Philippine Sea in June 1944 demonstrated the complete obsolescence of Japanese carrier aviation against American radar-directed defenses. The Japanese mobile fleet, commanded by Vice Admiral Jisaburo Ozawa, sortied with 9 carriers and 473 aircraft in an attempt to destroy American forces supporting the invasion of Saipan. Japanese planning assumed that superior Japanese pilot training and aggressive tactics would overcome American numerical advantages. The assumption proved catastrophically wrong. American Task Force 58, commanded by Vice Admiral Mark Mitcher, possessed 15 carriers with approximately 900 aircraft, overwhelming numerical superiority. More critically, American ships were equipped with the latest radar systems that provided comprehensive air defense coverage. The SC, SK, and SM radar systems aboard, American carriers could detect Japanese strikes while they were still over 150 kilometers away, providing nearly 1 hour of warning before attacks developed. The battle, which occurred on June 19 and 20, 1944, became known among American pilots as the Great Marianas Turkey Shoot due to the one-sided nature of the air combat. Japanese strike aircraft approaching American task forces were detected by radar while still far beyond visual range. American fighter directors vectored over 200 Hellcat fighters into optimal interception positions. The slaughter was comprehensive and absolute. Of approximately 373 Japanese aircraft that attacked American forces on June 19, approximately 300 were destroyed. American losses totaled approximately 29 aircraft, most to operational accidents rather than combat. The exchange rate was nearly 10-1 in America's favor. Commander Takeo Nakajima, the radar specialist who had examined the captured SC radar in November 1942, had spent the intervening 18 months attempting to improve Japanese radar capabilities. Now, watching the operational reports from the Philippine Sea battle, he understood with bitter clarity that his warnings had been accurate, but his efforts insufficient. The technological gap had not closed. If anything, American radar superiority had increased as newer systems entered service, while Japanese development remained hampered by industrial limitations and resource shortages. In a technical report submitted to the Naval General Staff in July 1944, Nakajima provided a devastating assessment. The Battle of the Philippine Sea confirmed everything we learned from examining captured American radar in late 1942, he wrote. American detection capabilities provided such comprehensive warning that our strikes were intercepted and destroyed before reaching attack positions. Our pilots reported that American fighters were positioned perfectly to engage our formations, suggesting radar-directed vectoring of interceptors with precision we cannot match. The loss of over 300 aircraft in a single day represents not tactical failure, but technological obsolescence. We are attempting to fight an air war against enemies who possess radar capabilities approximately 2 years ahead of our own development. The Americans can see us from distances we cannot match. They can coordinate defenses we cannot overcome. They possess industrial capacity to produce radar systems in quantities we cannot equal. The conclusion is inescapable. We have lost the technological competition that determines modern naval warfare. Vice Admiral Takajiro Onishi, serving as Chief of Staff to Admiral Toyoda Soemu, who had succeeded Yamamoto as Combined Fleet Commander after Yamamoto's death in April 1943, received Nakajima's report with resignation rather than surprise. Onishi had been a principal advocate of naval aviation since the 1920s, helping to develop Japanese carrier doctrine and training programs that had made the Japanese Navy's air arm the most effective in the world during the late 1930s and early 1940s. Now he watched that carefully constructed force being systematically destroyed by American technology that Japanese industry could not match. The Kamikaze Special Attack Program, which Onishi would later organize and command during the defense of the Philippines in October 1944, represented desperate acknowledgement that conventional carrier aviation could no longer achieve success against American radar-directed defenses. If Japanese aircraft could not survive long enough to reach attack positions against American ships, then suicide tactics that required only single aircraft penetrating defenses became the only remaining option. It was admission of complete technological defeat. The final accounting of the carrier war in the Pacific tells a story of American technological and industrial superiority, overwhelming Japanese tactical skill and operational courage. Japan commissioned 25 aircraft carriers of all types during World War II, ranging from large fleet carriers to small escort carriers. Of these, 21 were sunk or severely damaged beyond repair by war's end. Japanese naval aviation, which began the war with approximately 3,000 first-line aircraft and the best-trained carrier pilots in the world, ended the war with virtually no effective carrier capability remaining. The American submarine blockade and strategic bombing campaign destroyed Japan's ability to produce aviation fuel, train replacement pilots, and manufacture aircraft in sufficient numbers. But the immediate cause of Japanese carrier aviation's destruction was the simple fact that American radar made conventional carrier strikes impossible. Japanese aircraft were detected, intercepted, and destroyed before they could attack. American pilots, vectored by radar to optimal interception positions, achieved kill ratios that made continued Japanese carrier operations suicidal. Of the approximately 100,000 Japanese naval aviators who served during World War II, approximately 80% died, representing one of the highest casualty rates of any military service in the war. They died in burning aircraft shot down by American fighters directed by radar. They died in crashes attempting to land on carriers at night without adequate navigation equipment. They died in kamikaze attacks that represented the final admission that conventional tactics could not overcome American technological advantages. They fought with extraordinary courage and skill, but courage and skill could not overcome the fundamental technological disadvantage created by American radar superiority. The SC radar examined by Commander Nakajima in November 1942 represented only the first generation of American naval radar technology. By 1944, American ships carried multiple radar systems, providing layered coverage. The SM Fighter Director radar, operating at 518 MHz, provided precise tracking of individual aircraft for fighter interception. The SK Air Search radar offered longer range detection than the earlier SC system. The SG Surface Search radar detected ships and low-flying aircraft. Fire control radars directed anti-aircraft guns with unprecedented accuracy. American carriers had become floating electronic warfare platforms surrounded by invisible shields that Japanese aircraft could not penetrate. The post-war interrogation of Japanese naval officers revealed the psychological impact of fighting against superior American radar. Captain Toshikazu Omae, who served on the combined fleet staff throughout the war, provided testimony to American naval intelligence officers in October 1945. The examination of captured American radar in late 1942 showed us we were fighting an enemy whose technology we could not match, Omae stated during interrogation sessions at Yokosuka. Every subsequent battle confirmed this assessment. American radar provided detection capabilities that made our carrier strike tactics obsolete. We attempted adaptations, but each tactical modification was countered by American defensive improvements. By mid-1943, most experienced officers understood the carrier war was lost. We continued operations because abandoning the struggle would have freed American forces for other operations and hastened defeat across all fronts. Captain Atsushi Oi, who served as a staff officer in the Naval General Staff Operations Section, offered equally bleak testimony. American technological superiority was comprehensive, not limited to radar but extending to damage control, logistics, training, and industrial production. Oi told his interrogators. However, radar was the critical advantage that made all other American superiorities decisive. Because American radar detected our strikes from such great distances, American fighters had time to intercept our aircraft before they reached targets. Because American fighters shot down our aircraft before they attacked, our experienced pilots died while American ships survived. Because our pilots died, we could not maintain the veteran air groups that had been our greatest strength. The Americans won the carrier war through radar-directed defense that destroyed our offensive capabilities faster than we could replace them. The strategic bombing survey conducted by American forces after the war included extensive technical investigation of Japanese radar development and production. The survey teams discovered that Japan had produced approximately 1,600 naval radar sets of all types during the entire war. American production exceeded 50,000 naval radar sets during the same period, a 30-to-1 production advantage. Japanese radar development had pursued similar technological approaches as American programs, but with far smaller teams, less industrial support, and severe shortages of critical materials, including copper, rare earth elements for vacuum tubes, and specialized steels for antenna structures. Dr. Yagi, the physicist who had examined the captured SC radar in November 1942, provided technical testimony to American investigators in December 1945. Japanese radar technology was not fundamentally inferior in theoretical understanding, Yagi explained. Our scientists understood the same principles that American and British scientists employed. However, Japanese industry lacked the manufacturing infrastructure, the production capacity, and the resource base to build radar systems in quantities that would have tactical significance. We were attempting to compete in a technological race where the Americans possessed overwhelming industrial advantages we could never overcome, given Japan's limited resources and geographic position that made us vulnerable to blockade. The broader lesson that emerged from the Pacific Carrier War was that technological advantage multiplied by industrial capacity creates decisive military superiority that tactics alone cannot overcome. Japanese carrier aviation in 1941 possessed the best-trained pilots, the most combat-experienced leadership, and tactical doctrines proven through years of combat in China. These advantages proved meaningless once American radar provided defensive capabilities that Japanese technology could not match and Japanese industry could not counter through equivalent production. The side that controlled the electromagnetic spectrum, detecting enemy forces first and coordinating responses with precision, held advantages that no amount of courage or tactical skill could overcome. Commander Takeo Nakajima, whose examination of the captured American radar in November 1942 had provided the first comprehensive understanding of the technological disadvantage facing Japanese naval aviation, survived the war and remained in Japan. In a 1968 interview for a Japanese naval history project, he reflected on that November day 26 years earlier when he first powered up the American SC radar. When I saw the technical specifications and understood the detection ranges this American radar achieved, I knew immediately that Japanese carrier aviation faced obsolescence, Nakajima recalled. The Americans had not merely refined radar technology, they had deployed systems with capabilities we had dismissed as impractical or impossible. More devastating than the radar itself was what it revealed about American industrial capacity and technical sophistication. This was not experimental equipment. It was production standard, built in quantities suggesting American factories could manufacture radar as routinely as they built aircraft engines or radio sets. We were confronting an industrial power that could outproduce us in every category of military equipment while simultaneously developing new technologies we could not match. That realization, more than any battle or tactical defeat, showed me that Japan could not win the war we had started. The story of Japanese naval officers encountering American radar technology remains one of the most significant technological shocks in military history. It demonstrated that modern warfare is determined not just by strategy, tactics, or warrior spirit, but by industrial capacity and technological innovation deployed at scale. The side that could detect enemy forces first, coordinate defenses precisely, and replace losses through superior production held decisive advantages that traditional military virtues could not overcome. Japanese naval aviation, skilled and courageous as it was, found itself fighting a battle, already lost through technological and industrial inferiority. They fought on because duty demanded it, because abandoning the struggle would betray their comrades who had already died, and because hope dies slowly even when reason shows the cause is lost. But they knew. The examination of a single American radar set in November 1942 had shown them the future, and that future belonged to the nation that controlled the invisible electromagnetic spectrum through superior technology and overwhelming industrial might. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.